Everyone, and welcome back. Today we're going to be discussing freefall. So what is basically freefall? Freefall Freefall is the motion of an object whereby the only force acting on it is the force of gravity. When the force of gravity acts on an object, it's going to give to it an acceleration of 9.8 meters per second squared. Another way we symbolize it is by the letter g. Now, g and acceleration are exactly the same thing, with the only exception now is that it's a specific value of acceleration, which is 9.8 meters per second squared. We have two different types of freefall motion. The first one is unidirectional freefall, where the object moves in only one direction. We also have bidirectional freefall, where the object is thrown upwards and it changes direction. So first, let's look at unidirectional freefall. There are generally two different types of problems for unidirectional freefall. The first one is when time is given and distance is asked for. Let's look at the following problem. An object is dropped from rest and is allowed to freefall for 4 seconds, and we have to calculate the distance that it fell, the distance that it dropped. So what are we going to do? Very, very simple. We are going to use the distance time formula because that's the formula that connects distance and time. So as you know, distance equals velocity initial times time plus 1/2 at squared, acceleration times time squared, as you've seen from previous examples from previous classes. So when it's dropped from rest, so velocity initial is now equal to 0. So this now drops out. So we're trying to find this distance. So this formula now becomes 1/2 times the acceleration times time squared. So we just spoke about the acceleration. It is always going to be 9.8 meters per second squared. And the time now, as the problem gives us, it is going to be 4 seconds. And of course, we can't forget to square that. So the distance now, so 4 squared is going to be 16 times 9.8 divided by 2. If we do this calculation, we see that is going to be 78.4 meters precisely. So after 4 seconds, the object has dropped 78.4 meters. So that is one type of problem by which they can ask us to do. Another type of problem is if time is given and final velocity is asked for. Well, that case is very easy because we know the acceleration is 9.8 meters per second squared. So what does that mean? After every single second of free fall, the object is going to increase in velocity by 9.8 meters per second. So at the end of the first second, it's going to be 9.8. At the end of the second second, is going to be 19.6, so on and so forth. So in this following problem, we have an object is dropped from rest and is allowed to freefall for 4 seconds. Calculate the final velocity at the end of the 4th second. So in order to solve this, we need a formula that gives us the relation between time and final velocity. That, of course, is velocity final equals velocity initial plus acceleration times time. Velocity initial now is going to be 0, okay? Simply because, why? It simply drops, it's dropped from rest. So we're trying to calculate velocity final. We know what the acceleration is. The acceleration is 9.8 meters per second squared. And the time in this case, it is going to be 4 seconds. So when we multiply this throughout, we clearly see that the velocity final, it is going to be around 40 meters per second, and more precisely is going to be 39.2 meters per second. Two very easy problems for freefall. Thank you so much for joining me. I'll see you in class.